So when we're finding the reference angle theta prime, we're going to have a few different rules on how to find it if we're in quadrant 2, quadrant 3, or quadrant 4. Now, you don't have to worry about quadrant 1 because again, theta prime is that reference angle that's an acute angle formed with the horizontal axis. If we have first quadrant, theta prime is actually the same thing as theta because quadrant 1 would form an acute angle right there. So when we're in quadrant 2 though, okay, so let's say that we have an angle something like this. Our theta measurement is from the positive x all the way over to our terminal side, and theta prime is this blue angle here. Okay, so this blue angle here is modeled by theta prime is equal to 180 degrees minus theta, and that's if we're in degree form, and theta prime would be equal to pi minus theta if we're in radian form. Again, those are equivalent pieces on your study from the unit circle, okay? Pi or 180 degrees. Now, in quadrant number 3, it looks very similar, but just slightly different to quadrant number 2. Quadrant number 3, now we have an angle coming out here in quadrant 3, theta from the x-axis all the way to that terminal side, but theta prime, our acute angle actually goes back up to meet up with pi radians or 180 degrees. Okay, so here now, theta prime is going the opposite way, and that's exactly what's happened. We've gone from 180 degrees minus theta, flipped it around so that it's now theta minus 180 degrees is equal to our theta prime, and that again is if we're in degrees. And theta prime is equal to theta minus, not 180 degrees, but pi radians. Okay, so theta prime would be theta minus pi, and that would bring you back as well. So that's quadrant number 3. As for quadrant number 4, now we mix it up again, and our acute angle, as you can see here in blue, this theta prime is coming back around to 2 pi, or 360 degrees. And so our formulas to find theta prime are 360 degrees minus theta, and that's if we're in degree form, or 2 pi minus theta if we're in radians. Okay? So there we are. Those are the rules for quadrants 2, 3, and 4. In this video we're going to be finding the reference angle theta prime in 3 different cases. The first case is going to be where theta is equal to 300 degrees, so we're going to be using a degree format. In our second example, theta is equal to 2.3. Now, because it doesn't have a degree measurement on it, we're going to, that means that it's going to be in radians, because radians, again, does not have a formal unit. And lastly, when theta is equal to a negative 135 degrees. Okay? So, looking at this, just drawing a quick sketch. When theta is equal to 300 degrees, if we put this in standard position, 300 degrees brings us all the way around to here. So we're in quadrant number 4. And the rule for finding the reference angle theta prime when we are in quadrant 4 is we're going to take 360 degrees and subtract theta, and that's going to give us theta prime. So in our case, we're going to have 360 degrees minus our 300 degrees, which gives us a positive 60 degrees is our theta prime. Okay, so it's as simple as that, just recognizing which quadrant we're going to be in, and then going for it from there. Now, in our second example, what we have is theta is equal to 2.3. Okay, well, 2.3, we got to think of that in terms of radians. Well, here we've got 0 radians, and a lot of people would say 2.3 is going to be a full revolution around. But again, full revolution is 2 times pi, which is roughly 6.14, okay, which is more. So 2.3 is going to be less than half of that. Because here's pi radians on the other side. Pi is roughly 3.14. So we're somewhere around in here. This is our theta. Well, right now, we're in quadrant number 2. And the formula for quadrant 2 is that theta prime, using our radian piece of this, is going to be pi minus theta. Well, there we go. Pi, which we'll just take and approximate at 3.14 for this example, minus our theta value of 2.3, leaves us with a value of roughly theta prime is roughly 0.84. Okay, so it's just as easy as that, recognizing which quadrant we're in. Using that, let's go on to our third and final. Now we have theta is equal to a negative 135 degrees. Well, here we are, quick sketch. Now a negative degree measurement, this is something that we maybe haven't seen since section 1 of this chapter, when we started talking about positive and negative. A negative degree measurement indicates that we're going to be moving clockwise around our field here. So we need to go to a negative 135. Well, negative 135 degrees is right over here, because a negative 90 would put us at 270 degrees. So if we come over here, we're now in quadrant 3. And what we need to do is we're going to use our formula. Theta prime is now equal to theta minus 180 degrees. So here what we're going to get is theta prime is equal to a negative 135 minus 180. Now, the thing that's different here is we might have to go out and find our corresponding angle value instead of our reference. But this should work. Negative 135 minus 180 is actually a positive 315 degrees. Negative 315 degrees, which corresponds with 45 degrees. So negative 315 is, there's the negative 270. If we go another 45, we're right here, and our lengths are equal on either side. So theta prime is actually 45 degrees. Okay? So when you find these, if you get something like a negative 315, you might have to go and find the other corresponding angle. And remember, corresponding angles will add up to 360 degrees. Okay? So there we go, finding reference angles.